Bismillahirrahmanirrahim. Exercise 3.4, question number 2, part 3, integral Ex sine 2x cos 3x dx. The formula for integration by parts, integral fx gx dx equals to, considering f as first and g as second function, equals to first function constant, integral of second minus integral, bracket starts, derivative of first into the same integral, we close the bracket, and dx. Here we are going to use this formula, sine alpha cos beta equals to 1 by 2 sine alpha plus beta sine alpha minus beta. That is the formula of conversion from product to sum and difference in trigonometric functions. Using this formula, we convert sine 2x cos 3x and we get it is equals to 1 by 2 integral 1 by 2 into sine 2x plus x plus sine 2x minus x. As a result, we get sine 2x cos 3x equals to 1 by 2 into sine 3x plus sine x. Let's start the end. These are the rest of the integral formulas which we are familiar with. D by dx of ex is ex, integral sine 3x is minus cos 3x by 3, integral cos 3x equals to sine 3x by 3, and constants of integration. Now let's start integration. We have named the integral as I. Integral I equals to ex sine 2x cos x dx. We apply this conversion formula here and we write it like this. Integral I is equal to, let me see, integral I is equal to integral ex, in place of sine 2x cos x we write 1 by 2 bracket starts sine 3x plus sine x bracket close and dx. Now bring this 1 by 2 outside the integral and open the two integrals. As a result, you are going to get ex, integral ex sine 3x dx plus integral ex sine x dx. Now this is our integral I is equal to 1 by 2, then we have a bracket and we write the first integral as I1 and the second integral as I2, and we name this result as result number 1, and where I1 is equal to integral ex sine 3x dx and I2 is equal to integral ex sine x dx. Now we are going to solve integral I1. I1 is equal to integral ex sine 3x dx. We are going to perform integration by parts using ex as the first function and sine 3x as the second function. So we get integral I1 is equal to first function constant, integral of second function minus integral bracket starts derivative of first function d by dx of ex into the same integral, integral sine 3x dx, bracket close, and we have a dx for this integral sign. Now write the results from the sidebar. With the help of this sidebar, write these results there. Integral, you will get ex, integral sine 3x will be minus cos 3x by 3 minus integral derivative of ex is ex, and this is again minus cos 3x by 3. You close the bracket and we have dx. Now open up these brackets and you will get minus ex cos 3x by 3. This minus comes outside, this 1 by 3 comes outside, and minus becomes 1 by 3. We become plus and we get 1 by 3 ex cos 3x dx. Now again we are going to perform integration by parts using ex as the first function and cos 3x as the second function. So we again perform integration by parts, and what do we get? We get integral I1 is equal to minus Ex cos 3x by 3 as it is, plus 1 by 3, and then I put a bracket here and I'm going to perform integration by parts using first function constant integral of second function minus integral derivative of first function, that is inside the bracket I must write a bracket here, bracket derivative d by dx of first function into the same integral, integral cos 3x dx, close the bracket and another dx. So what do we get? This is equal to minus Ex cos 3x by 3 plus 1 by 3. Inside the bracket we have Ex sine 3x by 3 minus integral Ex sine 3x by 3 plus into dx, and here I'm going to introduce a constant of integration because I know that this is the last integral, and you will see in the next coming 2 steps that this is the last performed integral. So I get minus Ex cos 3x by 3 plus 1 by 3 bracket starts Ex sine 3x by 3 minus 1 by 3 integral Ex sine 3x dx plus c1, and we close the bracket. And now just see what was I1. I1 was integral Ex sine 3x dx, and what do we get here? We get integral Ex sine 3x dx. So I'm going to write I1 here. As a result, I will get I1 is equal to minus Ex cos 3x by 3 plus 1 by 3 Ex sine 3x by 3 minus 1 by 3 I1 plus C1. You can see we don't have any more integrals more integrals to evaluate. So this was the last performed integration. That is why we used C1 here, the constant of integration here. Now open up all the brackets and you will get integral I1 is equal to minus Ex cos 3x by 3 plus 1 by 9 Ex sine 3x minus 1 by 9 I1 and plus C1 by 3. Now bring this 1 by 9 I1 over to this side and you will get I1 plus 1 by 9 I1, and the remaining expressions will remain the same. I write them quickly. Minus Ex cos 3x by 3 plus 1 by 9 Ex sine 3x and plus C1 by 3. And now what do I get? When I add these two terms, I am going to get 1 plus 1 by 9 equals to 10 by 9. So I'm going to get 10 by 9 I1 here, and now I'm taking the advantage of whiteboard and erasing it, and I'm writing 10 by 9 here. So I got 10 by 9 into I1. Of course, you will have to write the next step, but I have adjusted this step. Now what I'm going to do, I'm going to multiply both the sides by 9 by 10. I have 10 by 9 I1 here. I'm going to multiply both the sides by, I have this thing 10 by 9 I1, and I'm going to multiply both the sides by 9 by 10 so that I get the value of I1. What do I get? This 9 by 10 and 10 by 9 both got cancelled. This got cancelled, this got cancelled, and I am going to get the value of I1, which is equal to, just open up all these brackets, and what you are going to get, you are going to get this 3 and 3 got cancelled, minus Ex cos 3x, 3 divided by 10 plus 1 by 10 Ex sine 3x plus 3 by 10 C1. This is the value of I1. Now we have to find the value of I2. What is I2? I2 is equal to integral Ex sine x dx. So let's go to the next page and we have to evaluate I2. I2 is equal to integral Ex sine x dx. What do? We are going to perform integration by parts using I1. This is the first function and this is the second function. So we perform integration by parts and we get first function constant, integral of second minus integral, bracket starts, derivative of first function into the same integral sin x dx, and we close the bracket and we have dx. So it is equal to Ex minus cos x minus integral sign and Ex and minus cos x dx. This becomes minus Ex cos x, minus comes outside, minus plus integral Ex cos x dx. Again perform integration by parts using Ex as the first function and cos x as the second function, and we are going to get integral equals to minus Ex cos x as it is plus bracket star. We don't need a bracket here, just perform integration by parts. First function constant, integral of second minus integral, bracket starts, derivative of first function into the same integral cos x dx, bracket close and dx. So I get minus Ex cos x plus Ex sin x minus integral Ex, and integral of cos x is sin x dx, and I know it is the last perform integral, so I am using a constant of integration, and you will see in the next two steps that why it is the last integral, last performed integration. What is I2? I2 is equal to integral Ex sin x dx. What do we get here? Integral Ex sin x dx. It means this is I2. So I'm going to write I2 here. I2 is equal to minus Ex cos x plus Ex sin x minus I2 plus C2. Now bring this I2 over to this side and you will get I2 plus I2, and on this side you will have minus Ex cos x plus Ex sin x plus C2. Now add I2 and I2, I2 plus I2 will become 2 times I2, and I am taking again advantage of the whiteboard and I am saving a step. I will get 2 times I2. In the next step I am going to multiply both the sides by 1 by 2 and I will use a bracket on this side. And now open up this bracket on right hand side, open up this bracket, and on left hand side simply cancel the 2 with the 1 by 2. Okay, these two got cancelled, and on right hand side open up the bracket to see the value of I2, and the value of I2 becomes minus Ex by 2 cos x plus Ex by 2 sin x plus C2 by 2. Now we are going to put both these values of I1 and I2 in I. Put I1 and I2 in result number 1. Result number 1 was I is equal to, result number 1 was I is equal to 1 by 2 into I1 plus I2. This is our result number 1. We are going to put the values of I1 and I2 in it. Let's put the value of I1 and I2. Integral I becomes 1 by 2. Value of I1 is minus 3 by 10 Ex cos 3x plus 1 by 10 Ex sine 3x plus 3c1 by 10 minus Ex by 2 cos x plus Ex by 2 sin x and plus C2 by 2. Open up the bracket and you will get minus 3 by 20 Ex cos 3x plus 1 by 20 Ex sin 3x minus Ex by 4 cos x plus Ex by 4 sin x, and I have collected the two constants at the end. We get 3c1 by 20 plus c2 by 4. Now put 3c1 by 20 plus c2 by 4 equals to c, and from all these terms take Ex by 4 common. Let's see what do we get. We are going to get the integral I equals to, we take Ex by 4 common, and inside the bracket I get minus 3 by 5 cos 3x plus 1 by 5 sin 3x minus cos x plus sin x, bracket close, and in place of these two I write C, and this is the answer.